this series of videos, we are going to be using the S500 build kit with the Matek F405 flight controller. This first video will cover the physical build of the project. In the second video, we will go over software configuration. We're going to start with the flashing of the firmware onto our Matek. Navigate to the initial setup page of ardupilot.org and then go to the loading firmware portion onto a board that does not already have existing firmware. The instructions on this webpage will teach you how to flash the firmware onto your board. Follow them exactly. Begin by first downloading all of the applications that you will need as well as the firmware files. Now we're going to connect our flight controller to our computer via the USB cable. When doing this, make sure to depress the button next to the USB port on the flight controller. Once this is done, we can navigate to the device manager portion of Windows in order to check that our flight controller connected correctly. If it has, we will notice it under the USB section. Now, launch the STM32 programming tool in order for us to flash our firmware onto our board. Once this loads in the upper right-hand corner, make sure that USB is selected and then hit Connect. Once this is done, the current hex code of our board should appear here. Now go ahead and hit the Open File button and select the firmware that you have pre-downloaded. Once selected, hit the Download button and we will begin flashing the firmware onto our board. This process can take some time, so please be patient. We can close the program and then open Mission Planner. In Mission Planner, select the right COM port and then hit the Connect button in the upper right-hand corner. Once the flight controller has successfully connected to Mission Planner, you can go ahead and move it around. Watch the artificial horizon in the upper left-hand corner and you should see it move. This means that the firmware has been flashed correctly and that our flight controller is operational. We will now move on to the physical build portion of this video. Here you can see all of the components of the S500 kit. This includes the flight controller accessories, the flight controller itself. You will also need a 3D printed bracket for mounting the flight controller, shown here. Next up are the 4 plastic arms, hardware and screws, the landing legs, power connectors, ESCs, the top plate and bottom PDB, a bag of zip ties and our battery connector, 2 slide bars, our 2 landing pads, our 2 pylon connectors, hangers and hanger gaskets, and our 4 motors, as well as our bag of 4 self-tightening 10-inch propellers. For this build, we'll be using the Newbie Drone Maintenance Kit, shown here. Inside are various tools that we will need for this build, including a soldering iron, screwdriver, solder, as well as several other smaller tools. For the soldering we'll be doing, it is advised to keep your soldering iron at approximately 420 degrees. Some other things we'll need are safety glasses for our soldering, as well as some thread lock. We will begin by assembling our motor arms. For this, we will need the 4 plastic arm mounts, our motor plates, our 4 motors themselves, and 16 of our M3x8mm screws. We will also need the correct screwdriver and our thread lock. For assembly, take your motor arm and check and see which side is opposite of these little ears here. We want the motor to be mounted on the opposite side of those. Take your motor base plate and put it on the opposite side of that and slide one of the screws in through the holes. Now, take that screw and thread it into the motor. Don't worry, we'll be removing this screw later so that we can apply our Loctite. This is simply just to hold the motor in place while we attach our other 3 screws. Once our motor is in place, we can begin by putting in the other screws. Take your screw, set it on your screwdriver, and apply a small drop of thread lock. Make sure it is not too much. We want only a single drop on these threads. When using thread lock, it is very important to keep it away from any and all plastic, so make sure not to rub it against any of the plastic arm when you're inserting it into the motor. Repeat this process for all 4 of the fasteners, making sure to remove your first fastener and reapplying thread lock to it. Once this is done, you can torque down all of the screws and make sure that the motor is mounted firmly. Give the motor a quick test spin to make sure that none of the screws are impeding on its movement. Once done, take the 3 motor wires and slide them through the underside of the motor arm. This is to ensure that they stay out of the way of the spinning propellers. Now repeat this process for the remaining 3 motor arms. Next, we can work on assembling our lower slide rails. For this process, we will need our hangers and hanger grommets, as well as our 2 slide rails, our battery pad. Take notice here that the plate is not reversible. One side has countersunk holes. These are so our screws sit flush. We will also need our 2 connecting rods and 4 of our M2.5 by 5mm screws, also thread lock and a screwdriver that is at M2.5. Begin by sliding the 4 rubber ring gaskets into our hanger pieces. This can be a little tricky, but just work through it and you'll be able to squish them in there. Now repeat this for the other 3 hanger pieces. Now begin assembling our parts. Take our 2 slide rails and slide our 4 hanger pieces onto them. Once they are done, use our connecting rods and connect the 4 pieces together. Take our battery pad and with the countersunks facing upward, attach it to the hanger connectors. Make sure to use Loctite on these fasteners as well. Now we're going to attach our base plate to our hanger assembly. For this, we will need our base plate, our completed hanger assembly, 8 M2.5 by 6 screws, as well as Loctite and our screwdriver at M2.5. Align the hanger pieces so that they fit onto the base plate by sliding them up and down our slide rails. Use the screwdriver to make sure that it's aligned, and once it is, we're ready to put in our fasteners. Like all screws in this build, don't forget to apply Loctite before screwing them in. With the base completed, we are ready to attach our landing legs. For this process, we will need our 2 landing pads, our 2 landing legs, 8 M3 by 8 socket crap screws, as well as 8 M2.5 by 6mm socket crap screws, as well as our thread lock and our screwdriver. Make sure to have both bits available as the screws have different sizes. We're going to start by first assembling our landing legs. Shown here, you see how they are attached to our base, out and away. Begin by first attaching the landing feet to the landing legs themselves. Unscrew them, simply slide in the landing legs, and then attach it. Once assembled, the landing leg can be attached to our base pad using the same process that we used for attaching the motors to the motor arms. Start by first putting in 1 screw so that it holds itself in place, and then, using thread lock, attach the other 3 screws necessary, applying thread lock to the last one at the end. Make sure not to tighten any of the screws to full completion before all 4 screws are inserted and the threads started. Once all 4 screws are inside, you can go ahead and torque it down. Repeat this process for both legs. Once both legs are attached, you can adjust them, making sure that the drone lays flat. Simply loosen the bolts at the bottom of the feet and then wiggle it until it lays flat before tightening them once more. The next section will involve assembling the connectors needed for our flight controller. We will need approximately 12 inches of 18 gauge wire, which will be cut into 4 pairs of 1.5 inch wire. Next, we will need 2 lengths of 14 or 12 gauge wire for our battery connector, and 4 Futaba connectors with female housing and male pins. We use 1.5 inch of 26 to 28 gauge wire, and will contain only the signal and ground pins. Make sure when assembling that you set up the signal and ground pin wires to match with the ESCs. Finally, we will need a male Futaba connector that has approximately 8 inches or more of 26 to 28 gauge wire and has all 3 connectors inside. It is also advised to have sections of heat shrink on hand so that we can clean up our connections. Cut and strip your sections of 12 to 18 gauge wire as shown. These will be soldered into our XT30 connectors. Be sure to note which end is positive and which is negative. When soldering the connectors, it is a good idea to plug them into a secondary connector to keep the pins from drooping inside the plastic housing. Now you're going to solder the two wires into the XT30 connectors. Make sure that they have a good solid connection before applying your heat shrink, and then repeat this process for the other three connectors. Once done, you will repeat the process for all four of your ESCs. Pay special attention to the positive and negatives on your connector. With the XT30 connectors complete, we can now move on to the XT60 connector using our 14 or 12 gauge wire. This connector comes with a plastic piece that we can use to clean up the build. With all of our connectors assembled, we are now ready to solder them onto our flight controller itself. Pay special attention to where the connectors are soldered in order to avoid damaging your board. In each corner you will see a negative pad, a small signal pad, and a positive pad. We are going to be using these three pads in conjunction with our XT30 connectors, positive and negative, onto both the positive and negative large pads, and the Futaba connectors are going to be connected from negative wire to the negative pad and the signal wire to the small signal pad. When soldering, I have found it advantageous to start with the smallest wire, the signal wire in this case. Solder the Futaba's signal wire onto the signal pad before moving on to the negative pad for both the Futaba and the XT30 connector. Once these are connected, we can then connect the XT30's positive wire onto the large positive pad of our flight controller. Once this is done, repeat the process for all four corners of the flight controller. We now have all of the connectors necessary for our 4 ESCs, including our 4 power and 4 signal. We are now ready to solder on our XT60 battery connector as well as the capacitor that came with our kit. On capacitors, the longer wire is the positive and the shorter is the negative, which will be attached to the battery connector pads. The final component we need to solder is our long Futaba connector. The signal, power, and ground wires will be connected in order: signal to S-bus, power to 4V, and ground to ground. With that, the soldering is done and we can move to attaching our flight controller to our 3D printed mounting piece. For this step we will need our flight controller, gummies, our 3D printed mounting piece, a single M3x8 screw, and 4 M3x12 screws and their corresponding nuts. We will also need our screwdriver and Loctite. On the 3D printed mounting hardware, you will notice that there are recesses where the hex nuts go. Begin by placing your M3x8 screw on the opposite end of these recesses and screwing on one of your hex nuts onto the end of the screw. We are going to then use this screw to pull the hex nut into the recess on our 3D printed mounting bracket. Once this is done, remove the screw. The hex nut should be flush with the bottom surface of the 3D printed mount. Repeat this process for all 4 holes. We are now ready to install our gummies onto our flight controller. The larger side of the gummy will go in between our flight controller and our 3D printed mount. To install the gummies, simply insert and squish them into the 4 mounting holes on the corner of the flight controller. Once this is done, we are ready to attach our flight controller to our 3D printed mount. Insert the 4 M3x12 screws into the holes in our flight controller. Now apply Loctite to the 4 nuts in our bracket and screw the flight controller onto our 3D printed bracket. Now tighten the screws until they are flush with the bottom of each of the hex nuts. We are now ready to attach our flight controller to the frame. The bottom of the bracket will be connected to the top of the base plate. The quad is oriented in this way, however, the flight controller is designed for the front to be facing in that direction. However, because of the battery cable connector, we want to connect it in this fashion. We will fix the flight controller's orientation later in the configuration video. For now, we are going to use our 3M strip provided to attach our flight controller to the base plate. Firmly attach the 3M pad to the bottom of the flight controller. Now, remove the paper and attach it onto the base plate. Try and get it as centered as possible. Once this is done, press down on the flight controller and the mount in order to seat it properly. Give a little wiggle to make sure that it is firmly attached. this point, we are going to want to insert the provided SD card. With the card facing up, slide it into the housing on the top of our flight controller, making sure that it is seated all the way. We are going to attach our 4 ESCs onto our flight controller, using the XT30 and the Futaba connectors that we soldered on. We are now ready to attach the motor arms onto the base. There are 2 holes in each corner of the base plate, which we will use to attach these motor arms. At the bottom of each of the motor arms is a small arch. This is where we are going to want our wires and connectors to go when we attach the arm to the base. The arms will be attached using 8 M2.5 by 6 screws. Make sure to use your Loctite when you screw the bottom of the arms into the base plate. Now screw in all 4 arms from the bottom, making sure that the wires are in the center. Once the arms are in place, we are ready to attach our top plate. Set the top plate into its space on top of the 4 motor arms. There are a total of 12 holes that we will need to use to attach the top plate. To do this, we will use our 12 M2.5 by 6 screws, as well as our screwdriver, and don't forget the Loctite. As we have done throughout this project, make sure that you put all of the screws with Loctite in slightly before you attempt to torque down any of the screws. Once this is done, you can go ahead and torque down all of them. With our top plate installed, we are now ready to attach our ESCs to our motors. Go ahead and plug in the 3 wires into the 3 corresponding sockets on the ESC. Don't worry about which order they are in, we will adjust them later when we are setting up our motor spin direction. With the ESCs attached, we are now finished with the build portion of this project. The final touches and cleanup will be finished in the second portion of this series, which will be configuring the aircraft.